Okay, perfect. So
you're audible and the presentation is visible. Yeah.
Okay. Okay. So we will go through these emerging trends, challenges, and solutions. And let's go with let's say with our agenda. Our agenda, will cover initially, what we see as acoustics challenges, trends, and then let's say more in the second part, we are happy to walk you to what are the solutions that we see at Ansys for acoustic with some examples. Then we will recall about, some deep dive sessions that, as Venki has started mentioning, we will have in the next weeks. And then, we have some open discussion. We are happy to have this interactive and answer to your question. So to start with, so let's see that introduce the topic, really considering that acoustics is really now everywhere. It's really involving all industry sectors. Automotive, of course, is a major one. Is also really in some ways it's bringing innovations. And it's also what we most experience in our day life. And but we have also other industries which are very important, like aerospace industries. Acoustics is becoming more and more important. We have new trends emerging like sustainability, regulations, and energy. Also, defense. We will show also some trends and some applications that are from defense industries. More globally about transportation, but also maybe our experience in consumer goods is something that we can touch for everyday life. How the products has also evolved to take more into account the acoustics, the noise, reducing the noise, and so on. High fidelity. And also there is some research and already some application about in healthcare that is using acoustics. So if you see this image, you might think it's really like an MRI image, but this is coming from ultrasound tomography, which is now started to be used also to generate these very high quality images, and it is much less, let's say, dangerous for the health than other kind of imaging screening. And here I just put like a quote from Dr. Alan Curtis, who is an expert in acoustics at Thales. Thales is a defense companies between the three biggest ones in Europe, but he's really giving a quote about more general acoustics, that he really sees this as a key enabling technology, and it is becoming more and more pervasive in all, let's say, industries. So now in the next few slides, I will just want to give some highlights about these trends in few industries where we see some more interesting, let's say, new things emerging. So the first one is aerospace and defense. So what we see here more as really requirements, and which is driving also all the industry, is really more stringent regulations for noise emissions. And we see this both for civil aircraft, but also there is a more regulation about airports. Airports sometimes are quite close to cities or populated areas. So it is not just about that, is all about the comfort and the noise levels in the airports. But we see also some increasing really demand from customer really. So people are getting more used to have quieter environments. Even in our day life in a car, and when we go into an aircraft, we are more sensitive to this compared to 20, 30 years ago. We see also some very interesting trends that are emerging and are not consolidated today, but we really see that this is going in the future. It's a future for us as a consumer, but is already, let's say, a reality from design perspective. So we have lots of customers, and we see already in the industry that there is lots of research projects about hybrid electrical vertical takeoff and landing. So what we call eVTOL vehicles, and that could be used as a city taxis, for examples, in the next future. So even though we don't still see them in our city, big companies are already investing in it, and they're already simulating this, because as you can imagine, then it will also be important from acoustic perspective for the noise emissions in cities. And last but not least, also in defense, of course, is not the primary goal is to have like a comfort acoustic goal, but acoustic technologies is really used a lot in defense. So an example is like to have quieter submarines, but also now you may know that there is much more drones technology, and the drones have to be quiet. And so sonar technology is advancing, and what is called anti-submarine warfare. And also there is more research going into acoustics in terms of advanced signal processing and machine learning, meaning that the technology is evolving in order to be able to understand even from acoustic perspective what kind of object is emitting this noise. Is it really like a drone, or is it some other kind of threats? And also, advanced signal processing is also started to be studied and used to locate also the noise source. So where is this noise coming from? You can also get information just from where the sound is coming through sort of beamforming techniques. On the right, I also put a quote about just to show how this is a really an active area of investment. Is like Thales has recently, like in July 22, acquired a company. It was already a participated company, but they fully acquired Advanced Acoustic Concept, which is, let's say, a company that is really dealing with advanced sonar and acoustic systems. And so just to show you, it's quite a big company with more than 200, 300 people and tens of millions of business. So which are the acoustic challenge that we see with this respect is really the prediction of all the noise source coming, for example, from an aircraft, which involve like jet noise, airframe noise, turbo noise, propeller noise, but also interaction propeller noise, for example, for the drones or city taxis, and all kind of absorption material liners. And then generally we have two big class of problems that we want to solve. One is if the receiver is quite far away, like you want to predict the noise from an aircraft which is approaching, for example, it's approaching like ground, or it's flying over a city, or you are also interested in the comfort inside the cabin. In this case, it is similar a little bit like what we've seen in the previous videos. You have really to go through the whole acoustic propagation from the different noise sources up to internal cabin. And just to confirm also the strong interest in all this, we have multiple research programs all around the world. I won't go into the details, but I just want to show, for example, we have like in North America, like at NASA, and just to show you, just looking at the first line of this table, how aggressive is also the target. So, for example, for noise emission, so the target of this AATT project from NASA is by 2025 to reduce the noise levels by 32 decibel, which is really huge. But just, their target goes really beyond and goes also about 20, 35 to go to 32, 42 decibel reduction, even up to 50 decibel reduction. So this is really massive, massive. And you can see how the perspective is in the long run up to, you know, the next 10, 15 years. In the central picture is some projects that are from Europe, and very, very, very important is the so-called Clean Sky project, and it's involving all kind of noise and research to reduce the noise. On the right picture are some couple of projects coming from Asia, which are on the same line with the previous one. So lots of investment in this area, and lots also of cascade technologies that can go in all different industries, as always happens with aerospace industries. The second one I want to talk about is what is more maybe one of the big experience in our day life is about automotive and transportation industry. Here, as also Dr. Venki was introducing, we see a new challenge. The new challenge is really electrification. So electrification is really posing a completely new perspective in terms of acoustics. If you see on this right-hand picture, we have the first plot, which is showing the internal combustion engine noise sources. And you can see that in the classic cars, so with a petrol engine, you see that half basically of the noise is really coming from the powertrain, right? But and here then you have the other noise source like road tire noise, wind noise. But once the vehicle is becoming much more quieter, as you see in the below plot, electric power, a train becoming, let's say, smaller in terms of amount of noise, then all the other noise sources are becoming more relevant, and this is quite interesting. So now we are all more interested in all these noise sources, in addition to the different kind of noise which is coming from the electric motor. And also here, the sound quality generally is now perceived more and more as an indicator of car quality. Before, as you might remember and experience, like only the segment of luxury cars, they were having this, let's say, this capability to be very, very good in let's say in comfort, in sound comfort and quality. But now everyone is also expecting for a small city car that it's very well insulated and the sound quality inside the cabin is good. Then there is also another trend that we see is also about speech recognition and infotainment and connecting systems. So it is becoming more and more important than it's not just if you want to talk inside the car, which is important, of course, but also when you say a command, vocal command, the acoustic of the cabin and the insulation has to be enough that this is perceived by your connected systems, and so the quality of the sound inside the cabin and of speech recognition is also becoming more important. And last but not least, you might see this upper right picture here. We put talking more generally about transportation. We see some some new trends, and maybe you have heard. I think it's a news about the last 2 weeks about Amazon has delivered the first parcel using drone technology. So this is also a new trend that we see in terms of technology. For some aspect is similar to what we discussed previously for the drones that will be used for let's say human transportation or also for military purposes. So what are the acoustic challenge that this is all posing? So first of all, the prediction and the higher attention to multiple noise source in general in the automotive, like HVAC system noise, wind noise, rolling noise. This is because, as we said, in electric vehicles or hybrid vehicles, the noise coming from the engine is becoming less relevant, but also the prediction of electric motor noise is something quite relevant, in particular also in terms of psychoacoustics, because the kind of noise can be a bit smaller as absolute value and some pressure level, but it can be much more annoying because it looks more like a whistle. And so psychoacoustics is also another area that is expanding, and as Patrick will talk more in the next slides, what are all the impact of this on human being and perception of the noise. The other thing is really to consider that we have all these multiple noise sources, and because technology is evolving, the industry is also expecting that you are not just simulating the noise sources, but really they want to know, okay, what is arriving at the end about all these noise sources up to the driver ear, what is arriving into the cabin. And not just considering these noise sources in isolation, but considering these noise sources all together. And this also will be discussed and also from Patrick in the next session. And then, as I said, is sound quality and speech recognition are the other challenges. The other, let's say, trends that we see emerging is really related to sustainability and energy. So examples you can see in these pictures is about like wind turbine, but wind turbines will not be only in this very nice picture, very picturesque picture put on the top of a mountain, but they are becoming more and more pervasive all around, and also in areas which are populated and will be populated. And then it's not just one, it's generally numerous number of wind turbines that are put in a sort of big plant. So this is becoming more important. Sustainability is also, let's say, creating more, let's say, everyone is more sensitive now to these aspects. And so also there are more regulations now about not just the pollution in terms of of emission of CO2, but also in terms of acoustics. The other thing that we see as a future trend is really like a smaller house-mounted wind turbine, which could be vertical, which could be mostly vertical, but also we have seen some horizontal examples. And then, as I was saying, we have more stringent regulation all around environmental noise problems. It is not just for wind turbine, it's for all urban areas. This is involving traffic, transportation in general. And interesting also, I was looking at some of the latest regulations. For example, you can see this below picture, environmental noise guidelines. This is coming from European Commission, but you have things around the world, like also Ministry of Environment in Japan. I had just a look at it. So this is also involving wildlife, even wildlife in outside of cities, but also sometimes, we start to, we also have some, wildlife inside the city. So everything is starting to be considered. And yeah, so we see also some interesting applications that we were involved at ANSYS, which initially we didn't really realize. And you can see this in these pictures about dolphins. So really now there is also attention to sea wildlife protection. And so underwater noise pollution is also starting to move some application and some research and some business. And then I did a bit of research and I found out that even like United Nations, as you can see in this small picture on the bottom right, it has some legislation. It is called Oceans and Law of the Sea, which honestly I was not aware of. But this is just to show you, how acoustics technology is really becoming pervasive and also now we see more application and more demand for underwater acoustics. So the challenge here are, all challenges related to airfoil noise, horizontal, vertical, wind turbine noise, but also, in the wind turbine you have an inverter, and so something similar to also electric motor NVH noise. You have to consider vibration and things like that. And then, as I said, also underwater and ultrasound acoustics are a field which are interested and for being able to address these new emerging trends. And with this, I will pass to Patrick to go more into the detail of acoustic sound aspects.
Thank you very much, Domenico, and thank you, SAE India, for giving us the opportunity to present the challenge of acoustic and NVH for India, but for all Asia. There is no doubt today that, as Domenico mentioned, that noise pollution has a growing importance. We can see many articles, papers explaining why noise pollution has become a major problem for human health and for the environment. Let's go a little bit in the details for the effect of noise on health. Next slide, please. Yes, one of the most evident effect of the noise on health is the hearing loss. Hearing loss, if you lose partially or totally the hearing sense until being deaf, it's really affect your life. And this arrived to workers who has worked all life long into factories, for instance. Now the trend is to have better monitoring of noise level into factories and for workers, and it's more controlled, but we still be aware that this is the most evident effect of the noise effect. But noise has also a lot of effects that are evident or not, such as disease and also psychological disease, when, for instance, it affects the quality of sleep. The concentration or learning trouble can be a side effect of a bad sleep. It's difficult to learn, to teach also if you do not have a good sleep, but it's also a direct effect if the school is close to the airport or close to the highway with low isolation. Then it's an evidence that all these trouble has social cost and economic cost and also industrial cost. Last year, according to a study published by the French Agency for Energy and Environment, the noise pollution in France has been estimated to 156 billion per year. This is a very huge amount, and among this, more than 100 billion is due to transportation. I mean the automotive transportation, the trucks, the railway, the aircraft, and we can realize how much importance for a society, for a country, the noise pollution can affect the life and how much it costs. And moreover, some cost of noise pollution cannot be evaluated because it's just a matter with life. And we have one estimation of the World Health Organization, and saying that noise pollution is so harmful that approximately 1 million lives are lost every year as a result of exposure to environmental noise. Well, saying this, let's see the advantage of acoustic comfort and better soundscape and noise control. Then, for sure, all what we saw previously regarding the effect of health will be highly reduced or totally avoided. And better concentration is one of the most important effects if you have some quiet room where you can work, where you can learn. Also, hearing conversation and better communication is definitely one of the most evident. It's difficult to speak when it's noisy. It's difficult to communicate even with active noise cancellation system in a noisy environment. And another way we can say also acoustic comfort and quiet environment allows us just to listen and enjoy the environment and natural soundscape. Reducing noise annoyance also helps to preserve nature and the wildlife, as Domenico has just explained with the dolphin, for instance. Another advantage of acoustic comfort and quiet environment is we can use sound to bring information, to bring pleasure also. And we can create sound to be an alarm to warn pedestrian for electric vehicle, for instance. And this sound will be clearly audible, and this cannot be achievable if the soundscape is too noisy. Then, noise pollution towards sound quality is a long journey, is a big challenge, and it can be only achieved step by step. And we have different steps toward the acoustic comfort or quieter noise. Next, please. And for sure, this is already a big step. The next step is when we reach the sound quality. And reaching sound quality is the ultimate challenge when you are acoustic engineer, NVH engineer, is to master the sound. And we want you to be a kind of chief orchestra, but no more dealing with noise pollution or just quieter noise, but also controlling the noise and give your product a brand identity. And we want you to be able to control and master the noise as if you were a chief orchestra. Next slide, please. The advantage of having a good sound quality for a product is very large. First, it will create the customer satisfaction. I mean that customer can enjoy using the product also because of good noise. For sure, we don't want to create a noisy exhaust system, but we know for automotive sometimes the sound of the powertrain is important. But we have some solution, I mean the active sound design solution for automotive to create noise inside the cabin and not outside the vehicle. And then we can give back about the power without be a contribution to the noise pollution. The advantage of sound quality for product will also reduce and avoid complaint about the sound and the overall perceived quality. If you have a good slam door into a car, it could be in a conscious way or not, but the overall perceived quality of the product will be improved. Master the sound, and being able to master the sound will be sure enable you to match the regulation and maybe to anticipate regulation, because noise is now monitored and is under regulation step by step in all countries. It's also an advantage, a competitive advantage. If you have a better sound, probably you can sell and increase the same volume. Then we know we have a lot of effort to do when we are fighting for noise and we want a better sound. But at one point, it's just not about noise reduction. If you are working on sound quality, you will have the return on investment about your work. And then sound and not noise, the sound can become an advantage for your product. Next slide, please. Actually, the sound perceived depend on the source, the directivity, and the power of the source, the functional point, the speed, the RPM of the source, the trajectory. It depends on the propagation. Will it be air? If we have a noise barrier, the sound propagation will be reduced, or if you are inside a house or a school or an hospital. And it also depends on the receiver. For regulation, most of the time, is just one microphone. It could be an array of microphone. If you want to certify, having a certification for aircraft, it's an array of microphone. And today, we want also to highlight that human perception is also a key for all the products that are used by human. Now, I would like to introduce the Ansys sound for acoustics and NVH. We talked about the source and the receiver. Let's discuss this in the automotive. And we can consider the engine, not alone, but inside a car cabin. Then we have the engine compartment and the passenger compartment. The source, let's consider the e-powertrain or ICE powertrain. It creates some vibration, and those vibrations will create acoustic wave. It will go to the front panel, and the front panel will vibrate itself and will go until the receiver. In addition, and this is the airborne conduction. In addition, we have also the powertrain on the mounting blocks, and that will create some vibration under the structure of the chassis and the body of the car. And all the body will vibrate also. This is the red path, and it will create the structure-borne conduction. And at the end, it's airborne because it arrives to the receiver. And after these two sources, we have also the aeroacoustic sources. We can also call it wind source. And wind source is coming all around the car. It creates some turbulence, and this makes everything also vibrate, especially the windshield, and the windshield will propagate also until the receiver. We can see how complex is propagation inside the car, and this is clearly a multiphysics domain. It includes structure dynamics, CFD and aeroacoustics, acoustics propagation, material. The advantage today is all this can be simulated thanks to CAE simulation software. At Ansys, we have many software connected all together. This can deal with measurements coming from test bench or real situation. This comes, or the results can be gathered coming from different simulation tools. One of them, one of the most famous in Ansys is Ansys Mechanical. And if we have the coupling with Ansys Maxwell, we can simulate the full e-motor noise. And using the finite element method solver for vibroacoustic, we can simulate many things in this domain. Another flagship product of Ansys is for CFD is Ansys Fluent. And this can simulate the sound of air conditioning, of cooling system, of wind noise over the windshield, as we saw previously. For the gearbox, we have also Ansys motion, and multi-body dynamics can be simulated thanks to Ansys motion, such as a gearbox, because e-power train is not just the e-motor, it's also combined with the gearbox, and this also creates some whining sound. I would like to also mention LS Dyna. LS Dyna has a very powerful BEM solver. It's used for crash test, but any deformation system can be simulated with LS Dyna, especially for everything with transient impact simulation. They have a BEM solver, very powerful to simulate all the propagation phenomenon. All these results from simulation and measurement can be gathered in one tool, which is Ansys Sound. And then we are able to listen the sound. We can analyze and perform acoustic calculation and psychoacoustic criteria calculation. We can compare the sound. You can compare the sound of two different design of e-motor, but you can also compare the sound of one e-motor virtual prototype and the real prototype and check if it's close or not. And if you want to optimize, you can design with Ansys Sound some target sound and then try to modify it with the CAD to achieve that sound. Let's give an example of multiphysics simulation for the e-motor. For the e-motor, the most common noise is due to electrical magnetic forces, and those magnetic forces are creating a radiation of the housing of the e-motor. With Ansys Maxwell and Ansys Mechanical, we can simulate the run-up and the pure tones emerging during this run-up. This can be calculated into Ansys Maxwell and Ansys Mechanical. Then it can be analyzed, and we can make it hearable with Ansys Sound. But we have also the CFD components, and CFD component is due to the cooling system because the e-motor is a source of heat, and to monitor and control the heating, we need a cooling fan, and this is typically aeroacoustics that can be calculated and simulated with Ansys Fluent, and based on the RPM, there is more or less sound, and this can be gathered into Ansys Sound to combine and to evaluate the importance of each source. And we can work, thanks to simulation, on a specific RPM, on a given RPM, for instance, to work on optimize the e-motor sound. I would like to share the global vision of One Ansys NVH offer for the full simulation workflow, but also including human in the loop. We saw previously that we can deal different components simulation with Ansys Sound, with Ansys Motion, Ansys Maxwell, Ansys Mechanical, Ansys Fluent, Ansys LS into Ansys Sound. Sometimes it's also an advantage to use some measurements, and we can deal with measurements. Next slide, please. And this is all about the components. Then we are on each component. If we go to a system level, we need to consider all the transfer path analysis. And for the transfer path analysis, we can use also test measurement, or we can use simulation. And we can deal with, as we saw previously, the structure-bound connection or the air-bound connection. But because most of the time, what is important is the human perception, it's important to be able to do listening tests, psychoacoustic experiments. This can be done into one lab, but this can also be done into a driving simulator. Another step toward the real situation is when you use in-vehicle experience. The advantage of electric vehicles and a high-end electric vehicle, they are very quiet. Then we can simulate also new type of sources while driving a real vehicle. We can see how much we go into the details to take account human in the loop of NVH sound design. And then, given this, we can manage the importance of the perception of different sources altogether. We can check which source is the most important, and we can also optimize the design of the unwanted source based on acoustic criteria, psychoacoustic criteria, or listening test experiments results. We talk about a lot about NVH for automotive, but let's talk also about other domains such as aerospace. For aerospace, we have one very good customer, which is Airbus Helicopters. Next, yes. And Airbus Helicopters is using our tool for in many different ways. They use recordings or CAE simulation tools. It could be internal tools or commercial tools. And Ansys has provided the 3D sound playback system for the soundscape rendering. Then into a lab, they are able to hear what will be in their future helicopters. We can run psychoacoustic indicators, including some special dedicated to aerospace. They can perform listening tests and assess the acoustic comfort. They can also, on a marketing point of view, they can also make the sound audible and choose some different option of acoustic treatment if it's VIP helicopter. And then they can listen the sound before manufacturing. And then the customer can choose the acoustic performance based on real listening experiments. And once the helicopter is delivered, sometimes they can face some default detection. They can feel bad sound. Sometimes they need to work on crash investigation. And both these default detection and crash investigation, our tool can also be used for this. We were talking about helicopters and aircraft, and it's the perfect time to give the ball again to Domenico to speak about the aeroacoustics sources. Thank you very much.
Thank you, Patrick. And so, yes, so let's, we have shown lots of pictures about aircrafts, about industries. Patrick has started to give some snapshot about overall picture on simulations. And I would like just to give you with the next slides very, few highlights about then the reality of simulation, what we can do. So here, this is just a snapshot pictures about what are some typical, simulation challenges that we have taken, we have addressed. We have validations, which is very important. And these are some few examples that we can show. For example, we have activities done on radiator fan noise, on blower acoustics. Also, as we said, there is emerging trends in electrification, but also in electronics, electronics cooling fan. We go also into combustion acoustics for some examples given by Patrick about the vehicle noise and side window noise and wind noise is something that we have worked on and addressed. The same for cabin noise. But we can go also on some aerospace application, which is involving validations and activities done on propeller noise, which can serve aircraft, but also drones. Drone simulation, And then we can go into more complex physics, like even a supersonic jet, industrial equipment. As you can see, also wind turbine and energy is a challenging but very very requested and growing topics. So this is just some of the applications that could fit into one slide. And but how do we achieve that? So what are the technologies and methods? So this is just a snapshot about, in Fluent, we have different methods and technologies. So we go from broadband noise models, we go to the right to acoustic analogy methods, and then we go to direct methods, and then we also have a coupling, so acoustic analogy, direct method, and we can couple to Ansys tools, but also to external tools. And then this is also about the accuracy of the turbulence modeling. It's about the solver technology. And we also have embedded some capabilities from Ansys Sound directly into Fluent. And I will show you just a small example. But I'm also very excited to talk to you about some evolving technologies in terms of solver. And so in Fluent, we are developing, and we have the first release in January about GPU, multi-GPU solver. This means that simulation can be accelerated by a factor of 10. And this is an example of a prototype on a drone simulation. The noise prediction is absolutely in our roadmap for GPU. So in addition to that, we already implemented some features directly into Fluent. And then we have a very good workflow, which, as Pat has shown, is really connecting Fluent to the Ansys Sound platform. One example is you can, what we say, listen to your simulation. So this is an example of the sound coming from a drone simulation. And this, this file you can directly create in Fluent. And you have much more advanced capability than in Ansys Sound, but there are some capabilities already exposed in Fluent and a very nice workflow to the platform of Ansys Sound. Okay, so let's go now also to talk about mechanical acoustics, and very briefly, because we have 2 dedicated sessions, as I will recall, next to go in more deep dive. So this is just like an introduction about what you will see more details in the next webinar. So mechanical acoustics, also to be able to address the challenges that we've shown, it needs some advanced solver techniques, and we have really FEM methods, BM method, but also statistical energy analysis methods. Then we can consider pressure acoustic problem, when here we are not considering let's say the vibration, and so we can do problems like muffler transmission loss or perforated plate transmission loss. But also what you can see on the very right picture is really what I was talking about in defense. So we have also application which involves sonar signal scattering, for example. And then we can go adding more physics and considering the vibration. And so we have all vibroacoustics applications. And here we have the radiation and the propagation. And so here we have a structure which are immersed also in the fluids. And some examples, they might include like speaker sensitivity, propeller, vibration, also underwater, and all automotive NVH, they fall in this vibroacoustics area. But we have also some advanced technology for viscothermal acoustics. This is some areas of application where the change of density of the medium of propagation is very important. So like you can have like a macro channel in if you have some basically some cell phones speaker, and so we have microchannel, and then the temperature is affecting the density, and this can make some difference in the sound estimate. Then we have room acoustics, and then we have random diffuse and sound excitation. An example is a launch vehicle where you have this noise is not just really affecting the human being, but it's so strong that the vibration induced by the noise, they can have they can really damage the delicate satellite structure. So this is really important problem. And this is a random diffuse sound nature. And then generally, most of the problems, they are treated more efficiently in the frequency domain, but we also have like transient acoustic capability. An example is like parking sensor analysis, that is done in transient to have really the realistic time domain simulation. And what also Patrick was mentioning is about being able also to consider impact noise. So this is an example of a ball and a plate, and there was an activity looking at different, let's say, material property thickness. This is a metal plate, and also inside mechanical, it is possible to listen to the noise. So now I will play it a few times, but you will really be able to perceive that this is a metal noise coming from an impact. So this is really rings like a bell, and you can listen to your simulation also in mechanical. So now going forward, between fluids mechanical and the other physics, as we have mentioned, we can couple these physics together, and we have also a good amount of set of validation on that. One example being the automotive that we discussed before by Patrick, and we have validations which is covering simplified models up to real car models, or we have simulations and application done for vehicle launch systems. But also, when we consider that excitation is not just the fluid flow, but can be electromagnetic field, harmonic forces, then they go to the vibration and sound, and this is also a coupling, let's say, physics between electromagnetic and vibration. We have a nice workflow for electric motors and all this kind of applications. So I would like just to recall, as Dr. Benki did at the beginning, that this webinar is an introductory webinar, and then we have two more sessions. So in the save the date, because we are really excited to go more into the detail about mechanical acoustics, and this will be on the December 15th, so 1 week from now. And we have our expert colleagues, Santosh, Ravi, and Yanhai, which will go through more details about CAE NVH simulation, involving testing and simulation, how you can optimize the acoustic performance. And then for who is interested more in the, let's say, noise generation by fluids, we have a deep dive, which is on December 21st, and here we go more into the details about fluids and CFD acoustics that we also call Aeroacoustics. And we look also here not just at Fluent, but also about multiphysics simulation and how all this is also integrated in our ANSI sound platform. So we're really looking forward to see you, and thank you a lot for the opportunity from CAE India to be here and to introduce you about ANSI solutions for acoustics. So thank you to also all the attendees, and we are also happy to get some questions. I think some of them they also might have responded by our expert colleagues in the chat. Thank you very much.